Hello, my name is Abigail King, and today I'll be discussing the chemistry of fossilization. Throughout our history, humans have been fascinated by organisms of the past, preserved in the form of fossils. Yet what if I told you that chemistry plays a large role in the process of fossilization? In fact, chemistry lies at its core. Typically, when an organism perishes, it lays upon the soil until it's covered in layers of sediment. Over time, along with pressure and heat, that organism is fossilized and is found by scientists of today and studied. Yet there's actually a complex chemical process that's occurring throughout this entire time period. This involves the sediment, the elements, and the compounds within the sediment as they make an exchange with the organic material of the organism, preserving it for millennia. Today, I'll be discussing three of the most common forms of fossilization. The first is called silicification, and it involves an exchange with the compound silica or silicon dioxide. Silicon dioxide has a molecular formula of SiO2 and is two oxygen atoms doubly bonded to one silicon atom. Fossils which have undergone silicification will appear blue and gray in color, and often this is a form of fossilization which marine organic matter undergoes due to the high silica levels within the ocean. The second form of fossilization is called carbonization. This involves an exchange with the element carbon. Carbon has a symbol of C, and fossils which have undergone carbonization appear brown in color, such as the tooth of Carcharodon's megalodon. Next, we have pyritization. This involves an exchange with elements sulfur and iron. Sulfur has a symbol of S and iron a symbol of Fe. Pyritization fossils are going to be golden and shiny in color, just like pyrite, which is where these fossils get their name. There are also other important factors which affect the results of fossilization or whether or not it occurs at all. One of these is pressure, heat, and the compounds or elements within the sediment. Pressure is going to be the amount of force that is pushed down onto the organic matter, while heat is the temperature. This can either be from it being buried or from volcanic activity. And then, of course, without the elements and compounds to make an exchange, that exchange might not occur. There's also a good way to differentiate between the exchanges, mainly through visual observations. Silica fossils will again appear blue and gray in color, which makes them unique. Carbon fossils are going to be brown, and they often retain some other types of etchings, including the skin, such as this fish fossil. And pyritization is, of course, going to be golden and shiny, just like pyrite. In summary, we've discussed the fossilization process, element and compound exchanges which occur, and some other important factors influencing fossilization. Here are my references for this presentation, and thank you very much for listening.